so the final section of this unit, we will be looking at sets of data in a table, and based on some different tests we're going to do on the table, we will be able to know if the data is linear, quadratic, or exponential. So I'm going to teach you the different tests that you do on the set of points so you know which set of data is which. Now, unfortunately, when we do the examples, you're already going to know what the data is since I'm going over the specific steps you use for the data. Okay, but in class, we're going to do some problems where I don't tell you what the data is, so you're just going to have some random tables, and using the 3 different processes I'm going to tell you, you can decide if it is linear, quadratic, or exponential. So let's look at our first example, which is on linear data. So, I have the steps here, which you don't have to write them down because they're in your notes. But it says what we're going to do. We're going to start with the second y value and subtract it from the y value to the left of it. Okay, that says it, not for. Sorry, I know that's kind of hard to read. That says it. Just going to rewrite that. Sorry, guys, that's embarrassing. Okay, so what we're going to do, this is called the first different test. So we're going to start with the second y value. When we do this, we only focus on the y values. So we start with our second y value from the left. Okay, so if you want to make a note of that, we do start from the left, not from the right. So my second y value to the left is the 3, and it says we subtract the y value to the left of it. So the y value to the left of it is the 5. So I'm going to start by subtracting these two. So 3 minus 5. Okay, which that gives me -2. Okay, we're going to continue this with the remaining y value. So I'm going to go to the next point and subtract the 1 to the left of it. So I'm going to go to my 1 and subtract the 3, which is to the left of it. So I'm going to do, this time I'm going to do 1 minus 3, which 1 minus 3 is -2. Okay, we keep continuing this pattern. So I start with the next y value and go to the one that's to the left of it. So I'm going to do -1 minus 1, which -1 minus 1 is -2. Okay, and finally, I'm going to be subtracting my final y value, the -3, to the one to the left of it, which is -1. And what I get, -3 minus a -1, so there should be a double negative in there. -1 or -3 minus -1. Sorry, guys. Did not leave enough space for that. So this will be minus a -1. Now remember, you guys, when you see a double negative, that will turn into a positive. So -3 plus 1 is -2. Now, do you guys see we get the same number each time we subtract one y value and the y values to the left of it? Okay, if that happens, if you subtract all the y values and the y values to the left of them and you get the same answer, you know your data is linear. And this is called the first difference test. So yay, this data is linear. Yay. Okay, now example 2. Kind of similar to example 1, but we have to take it a step further. So the next type of data we're going to look at is quadratic data. Okay, which are steps. The first thing we're going to do is complete the first difference test. So basically, I'm going to repeat what we did up here, and I'm going to show you what happens when you do that with some quadratic data. Okay, so we start with the second y value from the left of my table, which is a 6, and I'm going to subtract the y value to the left of it, which is 5. Okay, so 6 minus 5. Okay, this gives me a 1. So this is 1. Sorry, guys, I know I'm running out of space. Okay, now I go to my next y value. I'm going to do 9 minus 6. Okay, when I subtract those, I get 3. Okay, I'm going to subtract my next two y values, 14 minus 9. Okay, which 14 minus 9 will give me a 5. Okay, and my final two will be 21 minus 14, which that gives me 7. Now, if you see here, you guys, we did not get any of the same numbers like we did up here. So first of all, this tells us it is not linear. Our first difference test failed, so it is not linear. So it super fails, and we're sad. Okay, but not all data can be linear. So if our first difference test fails us, that's where we always start. So if the first difference test fails us, what we're going to do now is something called a second difference test. Okay, which the second difference test, what we're going to do, using the answers from the first differences, so I'm going to use these answers now, so we're only looking at the 1, the 3, the 5, and the 7. So using my answers from the first difference test, we are going to now do a second difference test. So I'm going to start with the y value, or my first different y value from the left, and subtract the previous answer that I got. Okay, which I'm going to be writing these down here, so I'm running out of space. Okay, which I'm going to just write my answers that I got up here real quickly. So I'm going to write, I got 1, I got 3, I got 5, and I got 7. Okay, so those were the answers from my first difference test. Okay, so now, using my information from the first difference test, what we're going to do now is I'm going to take my answers and perform a second difference test. So I start with my answer, that is second from the left, which is the 3, and I'm going to subtract the previous answer next to it. So I'm going to do 3 minus 1. Okay, which 3 minus 1 will give me a 2. Okay, I'm going to do the same thing here. So now I'm going to do 5 minus 3. 5 minus 3 will also give me a 2. Alright, then I'm going to subtract my last 2. So I'm going to do 7 minus 5, which that also gives me a 2. Holy hot dog, do you guys see we got a 2 every single time? So, if you do a first difference test and it fails us, and you use the answers from the first difference test and do a second difference test, and then you get the same answer, what you have discovered is quadratic data. So this is quadratic. Holy hot dog, you guys. Okay, so that would be my answer on this one. This one is quadratic data. Okay, now the final example we're going to talk about is when we have exponential data. So, exponential data. Okay, when we perform our tests on our points, the first thing we do is our first difference test. Okay, if we don't get the same answer each time, we move on to the second difference test. If that still fails us, what we're going to do is a new set of tests, which will be dividing instead of subtracting. Okay, so I'm just going to show you that this is definitely not linear and quadratic data by doing a first and second difference test. Okay, so my first difference test, let's get going. So these are the steps we do after we do the first and second difference test. So we'll address those later. So my first difference test. Okay, I start with the second y value to the left of my table, which is a 3, and I'm going to subtract these bad boys. So 3 minus 1 will give me a 2. Okay, then I'm going to subtract my next 2. So 9 minus 3 will give me a 6. Sorry, guys. 6. Then I'm going to subtract my next 2. So 27 minus 9 will give me 18. And then 27 minus 81, 81 minus 27 will give me, let's see here, 54. Okay, if you see, you guys, we definitely did not get the same answers. Okay, so my first difference test failed. So now what we're going to do is a second difference test. So let's see what happens with our second difference test. So now I'm going to be subtracting these. So we're doing our second difference test now. Second difference. Okay, so I'm going to subtract, starting with my second answer to the left. Okay, my 6 minus 2 gives me a 4. I'm going to subtract my next. My 18 minus 6 gives me a 12. And my 18 subtracted from my 54 will give me 36. So if you guys see, we still did not get the same answer each time. So this data is definitely not quadratic, definitely not. And it's also not linear because it failed the first and second difference test. So if that happens, now we're going to do kind of the same thing we did with the first difference test, except We're going to be dividing instead of subtracting. So we still start with the second y value to the left of our graph, but instead of subtracting, we're going to divide the y value to the left of it. And then we'll continue this with all the y values. So let's try our constant ratio test, which I'll explain why it's called a constant ratio test. So this is my constant ratio test. So constant ratio. Okay, so I'm going to start with my 3 and divide it by 1. Okay, which 3 over 1 will give me a 3. Okay, then I'm going to move on to my next one. So I'm going to do 9 divided by 3. Okay, which that will give me a 3. Okay, I'm going to move on to my next one. I'm going to do 27 divided by 9. Which that also gives me a 3. Maybe you guys are seeing a pattern. And then I'm going to go to my last y value. So I'm going to do 81 divided by 27. Which guess what, you guys? That also gives me a 3. Okay, so again, basically I took all these same values, but this time we just divided them. Okay, and if you divide all of your y values and get the same answer each time, you have found something called the constant ratio, and this is the value of my constant ratio. So my constant ratio value is a 3. Okay, and if you get the same constant ratio each time, that means your data is growing at a constant rate, which means it's exponential. Yay, it's exponential. So this data is exponential. Wasn't that cool, you guys? So again, always start with the first difference. If you get the same answer each time, it's linear. Then move on. If that doesn't work, then move on to second difference test. If you get the same answer each time, that's a quadratic. But if that fails, you move on to your constant ratio test. And if you get the same answer each time, you have spotted exponential data. Awesome job, you guys.